I'm sharing my screen. Did you get my screen? Our screen থেকে দেখা যাচ্ছে তোমাদের?
জি স্যার।
Okay, let's start. In data structure, we already learned from the very beginning that there are two types of structure, that is preemptive and non-preemptive. Preemptive data structure, that is basically dependent on the compiler, dependent on the very basic data types, that is character, integer, float, double, all those things that are we are regularly used in the compiler, any programming language. But the non-preemptive data structure, that is basically formed using the combination of the different preemptive data types. And non-preemptive data types are two types, that is the linear structure and non-linear structure. And everybody, you know what is the data structure. Data structure is the particular organization or orientation of the data. And we are the student of computer science. We are basically deal with the data, how the data arrange, organize, and retrieve. So we study different type of data structure, that is array, linked list, stack, queue, and tree, graphs. So far we are study array or linear list, sorted list, unsorted list. And today I am discussing one particular type or very important type structure, that is stack. We have two different types, stack and queue. Both are the linear list. Stack is a special type of structure where data added and remove only one end, not the both in, not the middle. You know, last class in list or sorted list or unsorted list, we can add or remove data from the first, middle, or even in the end. But stack and queue have some limitations, some binding. We cannot add or remove from everywhere. For the case of stack, we can add or remove from the only one end of the list, and this one end is called the top. So in the formal definition, we can say there are certain frequency situation in computer science when one wants to restrict insertion and deletion so that they can take place only at the beginning or at the end, not in the middle. So for the stack, we can add and remove only one end, and this is called the top. For the queue, we can add and remove in the both side. Normally, we add in the one side and remove from the other side. The side we add, that side we call the rear, and the side, the item remove, that is the front. This is a stack of a coin. We see the figure. Normally in coin or something like that, that is the dishes. We put the dishes only one in the top, and we also remove from the top. We do not remove or insert any dishes in the middle. Normally in the real life situation, when wash or take we dish from a stack of the dishes, we remove or add only at the top of the stack. Okay, so you can define the stack. A stack is a list of elements in which an element may be inserted or deleted only at the one end called the top of the stack. Okay, a stack is a list of elements in which an element may be inserted or deleted only at one end, called the top of the stack. And the stack ADT, abstract data type, in stack ADT we have two basic operations that are related with the stack, that is push and pop. Inserted an element into a stack, that is the push, and pop is the process of deleting or removing an element from the stack. Normally in sorted list, unsorted list, or array or linked list we call the insertion, but in the stack we call it push. The process of adding or inserting an element into the stack we call push, and the process of removing or deleting an element from the stack we call the pop. Wait. Okay, I think everybody you are fine my slide. My slide is visible to everybody?
Yes, sir. Yes, sir.
Yes, sir.
There is some problem. My pad is not working. Yeah. Okay. Stack store a set of element in a particular order, and stack principle we call last in first out. The element added in the list at the last, that will be out at the first. So it is called the last element, last in first out, because the last element always in the top, and we can move any element or remove any element from the top only. It means the last element inserted is the first one to be removed. So always remove the top. This is an example of, this is initially the empty stack. Okay. Wait. Okay, this is initially empty state. When we add an item, say the item is A. We want to add in the A. So the first element is the A, and now the top is A. Sorry, top is 1 and the element is A. So this is the top. Right. Okay. When we want to add another item, at first we have to increase the value of the top. Initially the top is 0, then when we add one item, the top will be 1. Now we increase the top, that is 2, and we can add another item, that is B. So every time we add, actually for the stack we cannot say the add. Every time we push an element into the stack, that always will be in the top. And similarly, when we remove any element from the stack, that also will be the top. So we cannot pop A unless we pop C and B from here. Figure number 3, we cannot pop A. We have to pop C. We can
C.
always we have to pop the top element. Okay. So this is the. Have you any question?
No, sir.
Okay. For the stack, we have to push or pop only the top element. We cannot push pop from the inner element anything. For the figure 4, we can pop only the top element, that is the D. We cannot pop A unless we pop D, C, B. Representation of stack. Stack can be represented in 2 different ways, linear array and one-way linked list. That I already told you that in the data structure, all the structure of the stack, queue, tree, graph, hashing, all the structure can be implemented either you can use linear array or one-way linked list. That is the procedure. Okay. This is the array representation of stack. In for the array is a linear list where the indexing actually start from the 0. When we use the stack, we start from the beginning element is 1. Initially the stack is empty, and when we add A, that will be inserted in the first element, and that will be top. After that we want to add B, that so we need to increase the top, that will be 2, so the B inserted in the next element, and after that C we insert it, and in the top element C. Now if we want to add D, then where we can add? Okay, say this is our stack. So this is index 0, 1, 2, 3, 4, 5. The initially this is our linear array. We can say the array name is stack. So stack is a array. We give integer int stack, and how many element is there? 6. Initially the stack is empty. Now we want to add 10. So where it will be? The initially the top will be -1. So we want to add 10. What we have to do? We will do top equal to top plus 1. Then what will be the value of the top?
0.
Top initially -1. So when we increase top equal to top plus 1, what will be the value of the top?
0.
0. So we add 10, our element in the 0 position. So this is our top. So if we want to add another element, something like that 20, so what do we have to do?
20 push করতে হবে
Okay, this is the process. Step top. So step top equal to 10. We have to do this procedure again. We need top plus plus or top equal to top plus 1. Then new value of the top will be 1 and this is our value 20. Now if we want to 30, so what we have to do? Top plus plus and we push the value of 30 is here and this will be our top. We want to add 40. What we will do?
Top plus plus. Push
Top plus
40.
plus and we do
Push 40.
we push. Okay. Now if we want to 50, then we push 50. Now 60. Now we want to 70. May I add 70 in the stack? Is it possible to add 70? সেভেন্টি কি অ্যাড করা যাবে এখানে?
ফুল হয়ে গেলে স্যার অ্যাড করা যাবে না।
আচ্ছা, এই সিচুয়েশনটাকে আমরা কি বলবো?
ওভারলোড।
Overload.
Overflow.
ওভারফ্লো।
If the list is already full or if the memory is already full and we want to add any item in the list, that situation we call the overflow. So this is the procedure of push. And what is the coding of the top 0 or top equal to null will indicate that the stack is empty. আচ্ছা, তোমরা ঠিক মতো শুনতেছো তো?
জি স্যার।
জি স্যার।
So if the top equal to max stack, that's mean for our example here you see this is when our top, now top is 5, this is the max. So when the top equal to max, that is the situation is overflow. So when if top equal to max stack, then print overflow and exit. Stack already full. Otherwise, we say top equal to top plus 1 or top plus plus. And number step 3 is the set stack top equal to item. Here we say stack top equal to item. And this is the very simple algorithm to push any element in the stack. First we have to check is their stack already full or not. If the stack is full, then we cannot push any element in the stack. We just print the message or give the message that is stack already full, and the situation we call overflow. Then we say top equal to top plus 1. If this condition is false, then we say top equal to top plus 1. We just increase the value of the top, and after that we push the element that we want to add, that is stack top equal to item, and the last statement is the exit. This is the push operation. And now the pop operation. When we are popping an element from the stack, we have to check that the list is already empty. We cannot pop any element from the empty stack. So if the top equal to 0, then we can say that is the stack is already empty. So what is the value of the top? Value of the top is -1. So we have to check if top equal to -1, print. What is the situation when the list is empty and we want to remove any element from the list? This situation is called underflow. When we want to delete any element from the empty list. But otherwise, we have 10, 20, 30, 40. Okay. What is the value of the top? Value of the top equal to 3. So if this condition is false, that is our list is not empty, then we simply do top equal to top -1. And the item we want to remove, we set here the stack. This is the situation and this is the push operation. If top equal to 0, then print underflow. Otherwise, set item equal to stack top and set top equal to top -1 and exit. Okay, actually we have to first remove the item. This statement will be later. After removing the element, we set top equal to top -1. Okay, this is the pop operation. So there are two operations related with the stack, that is push and pop. Push is the process of adding an element in the stack and pop is the process of removing an element in the stack. And we see the linear array representation. Now we see the linked list representation. How can we implement the stack using the linked list? In linked list, we are already discussed that insert at the first, remove from the first, all those things. So in the linked list, if we consider the head is the top, then when we are pushing any element in the stack, we are simply adding the first at the beginning. So the head is always is the top. So any element we are pushing in the stack in linked representation, actually we are adding at the first. Always we add any element in the first. So how can we do this? And this initially the linked list is empty. So we want to add, this is our empty node. We call it temp. In linked list we have no collection of node. Is it, do you remember that? The first one is called information field and second one we call link field. This is the link field and this is the information field. So when we are want to implement stack using linked list, we actually initially create an temporary node. So this node have two field, one is information field and one is link field. So we want to add 10. So this 10 will be the information field, and the first node, the link field will be the null. This is null. And we have a special pointer that is the top. We call it top. So this top actually link to the first node. This is we call top. Okay. If we want to add another item in the linked list, then we will take another node. This node have also two field, one is information and another one is link field. Okay, we add 20 here. And the rules for the stack that we always push at the top only, the first element. So we need to change the link field from here to this one will be there. Oh, sorry. And we remove this. Sorry. We remove this link. And our new top will be this one. So the top, now the top is 20. So every time we push any element, that always will be the first or top element. Now if we want to add another node, what will be? This is like that. We want to add 30. Okay. Then this 30 actually link to this one, and we remove this link. Now the top is this one. So now for the stack, the first element, the top is 30. This is 30, the first element. This is 20, the second element. And 10 is the third element. This is the push operation using linked list.
স্যার স্ক্রিনে কোনো চেঞ্জ হচ্ছে না।
স্ক্রিন দেখতে পাচ্ছ না? আমার হোয়াইট বোর্ডটা দেখতে পাচ্ছ?
না স্যার।
হোয়াইট বোর্ড দেখা যাচ্ছে না? হ্যাঁ হ্যাঁ।
না
মানে
স্যার।
তোমরা এই পর্যন্ত একবারও হোয়াইট বোর্ডটা দেখো নাই?
না স্যার।
না স্যার।
না স্যার।
হ্যাঁ হ্যাঁ। ওকে ওকে। এখন কি দেখা যাচ্ছে?
জি স্যার।
জি স্যার।
হ্যাঁ হ্যাঁ, আমি তো তোমাদের অনেকগুলা ইয়া দেখাইছি। ওকে, আমি অ্যাটলিস্ট এইটা আবার তোমাদের দেখাই, দাঁড়াও। তোমাদের হলো তো ওই যে আমি ওভারফ্লোর জন্য এটা দেখা প্রথমে হলো অ্যারে বেস এর জন্য এটা দেখাইছি। ওকে, দেখতে পাচ্ছ তো? হোয়াইট বোর্ডটা দেখতে পাচ্ছ?
জি স্যার।
ওকে। For the implementation of linked stack using the linked list, we have to create node. So this is the node. This node have two field. One is information field. Another one is link field. Is it? And for the linked list or pointer base, when the top equal to null indicate that initially the stack is empty.
we want to add 10. So this is our the first element, and the next field will be the null. So what happened? We are implementing stack using the linked list. Initially the top will be null. The first, when we want to add the first element, that is 10, we need to create a node. This node have two field, one is information and another one is link field, and we add 10 to here. And we always maintain a special pointer, that is the top. Top actually link with the first element or top element of the stack. In the stack, the top is the first element, and you know everybody, for the case of stack we can add or remove only at the
Top.
So if we now want to add another item, so we have to create another node. Every time we add new item, then we are creating a new node. So this will be 10 we are adding, and this link field will be linked to here, and we need to change the top, because initially the top is 10, but when we add 20, this 20 will be the top. So we remove this one. We are adding this 20. Now the top is 20. So this 20 will be the top element. Now if we want to add another item, something like that, we are creating a new node, that is, and we are adding or inserting 30. So this, sorry. So this 30 is, we take a new node and add 30 to here. Now we need to push this 30 into the stack. So this 30 is linked to here, and we need to remove the link and have to create new link with 30. Now the top is 30. So when we implement stack using the linked list in link representation, so every time when we adding a new element or new node, that will be the top. So we just simply change the top pointer. Okay, here you see the link representation. Initially the A is added into the list, then B is added, then C is added. So what is the top? Top is C. If we want to remove, if we want to pop an element, then what will be pop from this list?
C.
C. After that B, and last element to be popped, that is A. So this is the push operation. So for the push, we always push or add an element at the top pointer. This is simply implemented in the linked list. I will see you the in link structure. We have a add in the first. Do you find the code? C code. You are see my slide.
Ji sir.
Okay. What is the process of adding? If head equal to null, actually we replace this head by top. If top equal to null, set top equal to 10. We just use only this code. Okay. This is the code for the stack push, because for the pushing, we have to always add at the beginning. In the linked list, we already know how to add at the beginning. So for the push operation, we are also always adding at the beginning. So this is the push operation using the linked list, and this is the algorithm new info equal to item. So initially we take new, even we can say this is the temp. We can use as a temp also. Temp info temp link in equal to top equal to temp. Initially we need to take a temporary node. We add our item into this information field, and we set this temp into top. This is the push operation. Only 3 statements. We need to take, initially we take a temporary node. After that, we add the item that is we want to push in the stack. We add the item this node. We create a link here, and we just change the top from this element to this element. This is the procedure of the push using linked list. Okay. This is the push operation. Void push. In name we have to give the parameter what we want to push in the stack. If is full, so stack is full and return. Normally when we use the linked list, we implement the stack using the linked list. This statement will not true, because for the linked list or link representation, we only take one element or one node. This is may never happen that the linked list will be full. So we said, okay, this is actually using array-based representation. This code is for the array-based implementation. We see array-based. This is the array-based algorithm, and this code for the array-based implementation. Okay, let's check the for. Okay. Where is the pop operation? This is the pop operation. Okay. Link based pop operation is stacked before the pop operation. We have 4 elements D, C, B, and A. What is the top element? Top element is D. And after removing the top element, we simply change our pointer that is previously linked to D. We shift or we change this top to C. So this D will be removed from the list. Very simple way. If we remove these things, we are removing and we make change this one to here. So now the new top will be C. We just simply change the top from D to C. And this is the algorithm for pop operation. If top equal to null, that is indicate the stack is empty, and we write overflow. This is actually not overflow, underflow. Underflow when we want to remove from an empty list. And set item equal to top info, and we increase the top value. We increase the value of the, or we update the top value. So this is the today class. We are discussing what is the stack, and we are discussing two operation, that is push and pop. So today class we discuss what is stack, structure, how can we implement stack, using array and linked list. Number 3, two operation related with stack, that is push and pop. Number 4, push pop algorithm. Implementation of push pop and pop in array. ওকে, তোমাদের টাস্ক হলো নেক্সট ক্লাসের আগে পুশ এবং পপ এই দুইটা অপারেশন ইমপ্লিমেন্ট করবা অ্যারে বেস এবং লিংক লিস্ট বেস। কোডটা আমাকে আমি অ্যাসাইনমেন্ট ক্রিয়েট করে রাখতেছি ক্লাসে, সেখানে তোমরা সাবমিট করবা, ঠিক আছে?
জি স্যার।
আমি হলো তোমাদের ইয়াটা সেট করি। তোমরা ইয়াতে থাকতে থাকতে আমি অ্যাসাইনমেন্ট সেট করলাম। অ্যাসাইনমেন্ট সেট করলে এটা হলো তোমরা ফাইল আপলোড করতে পারবা। আচ্ছা, অ্যাসাইনমেন্ট অন স্ট্যাক implement push and pop
স্যার আমরা কি ডক ফাইল দিব নাকি সোর্স ফাইল?
সোর্স গুলাই ডকে করে দিবা একটা ফাইলে। implement push B হলো পপ, নাম্বার আচ্ছা এ হলো অ্যারে বেস, নাম্বার 2 হলো আচ্ছা উল্টা করি আর কি, এটা সুবিধা হবে। এ অ্যারে বেস পুশ 2 হলো পপ। ওকে, লিংক লিস্ট বেস পুশ এন্ড পপ, এই হলো তোমাদের অ্যাসাইনমেন্ট। তোমাদের সময় কিন্তু কালকেই, ঠিক আছে? ওকে, সরি। টপিকস দেই হলো ক্রিয়েট অ্যাসাইনমেন্ট।
স্যার অ্যাসাইনমেন্টের জন্য কতদিন সময়?
কালকে দিবা।
স্যার আমাদের
কতদিন সময়?
স্যার সিটি আছে আগামীকাল একটা।
সিম্পলি পুশ আর কি হয়েছে?
স্যার আগামীকাল সিটি আছে আমাদের ওপির উপরে।
আচ্ছা তাহলে যাও তারপরের দিন, কালকে হলো কয় তারিখ, 13 তারিখ তাই না?
জি স্যার।
যাও 14 তারিখ দিলাম,
জি স্যার, থ্যাংক ইউ স্যার।
14 তারিখ যাও 12 11টা। ওকে, এই ক্লাসে দিবা।
জি স্যার।
আর আজকে তোমরা হলো যারা আসো তোমাদেরকে হলো অ্যাটেন্ডেন্স দিতে বলছিলাম হলো ইয়াতে, তোমাদের ক্লাসে কিন্তু অ্যাটেন্ডেন্স একটা সেট করছি, মাত্র 15 জন দিছো, ঠিক আছে? তোমরা হলো 23 জন পর্যন্ত প্রেজেন্ট ছিল এক সময়। ওকে, সবাই ভালো থাকো।
স্যার আসসালামু আলাইকুম।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।
স্যার আসসালামু আলাইকুম।